Hi, I'm going to show you how to find virtual images using a curved mirrors. Now keep in mind there are two different types of curved mirrors. Here we have a converging mirror over here, so converging mirror. And then we have a diverging mirror over here. Make sure you have printed out this sheet because it'll make note taking a lot easier so you don't have to draw out these curves or anything like that. Also, here we have the line, which we labeled the principal axis, and then you'll notice that I've placed a candle. Now, this candle for the converging mirror has to be placed or must be placed between the focus and the actual mirror itself. All right. If you place it somewhere else, you're not going to get a virtual image. So, we'll talk about the diverging mirror after. All right, so let's find the virtual image. There's actually some standard rays that you will draw every time you draw a ray diagram to find these images. Okay, so the first step is you're going to draw a light ray coming from the candle. So I'm going to have this a nice sharp point, ideally a pencil. I'm using a pen so you can see my drawing a little bit more clear, but for you a pencil would be better. All right, so we have the light coming out of the candle. It's going to hit the shiny surface of the mirror, and then remember it's going to reflect through the focus. So let's draw it through the focus. Okay, and it is a virtual image, so with all virtual images, just like the flat mirror example, the images you need to see with an eye, and it's in the mirror. So this here, the light ray that I've drawn is the reflected ray. So basically what will happen is that if you place your eye over here, you will see the image in the mirror, and your eye thinks that the light came from back here in a straight line. Because remember, light travels in straight lines, where we believe that so strongly that even though the light has been reflected or bounced off a surface, we still think the light has come from the mirror. So this is the eye. So this is the first ray that you always draw. So let's write that down, and that'll be in the blue, and I'll have step 1. You're going to do parallel to the PA. So parallel, okay, to the principal axis, and then 2, you're going to hit the mirror, and then it's going to go through F. So then you're going to draw through F. So when you draw through F, just don't forget to back, okay, to make that dotted line. Behind anything behind the mirror is dotted. Okay, I'm going to do the next ray diagram using a different color. So the next ray diagram is like this. You're going to have it through F and then parallel to the PA, okay? Because remember, light's kind of reversible in that way. So I'm going to do through F like so. So you notice that the light is coming as if it's going from the focus and then parallel to the principal axis. So I'm just going to make sure it's parallel. I think that was looking pretty parallel right there. Oh, let's try that again. Parallel. Okay, and remember, anything that's behind the mirror gets replaced by a dotted line. Okay, so the light, as you can see the diagram, is from the candle, bounces off the mirror, and that way. Okay, this light as if it came from the focus. Here, same thing, the light is coming from the candle and then bounces towards the focus. So this here is step 2. Step 2 or ray 2, we have pretty much from the focus, okay, or through the focus if you like, through the focus, so through F. Oops, that would be step 1, sorry, step 1. And then step 2, that will be parallel to the principal axis. Okay? So that's 1 and that's 2. So recap. You have step 1, parallel, then through F. Step 2, through F, then parallel. Now, those dotted lines, where they intercept is where your image will be. So back here is going to be the image of the candle, which I will draw right here like so. So that is the image of the candle. And since we drew it from the tip of the candle, that wherever they intersect, that is also the tip of the candle. Okay, so what are the characteristics of this candle? Well, it is a virtual image because it's made by dotted lines. Okay, it's also behind the mirror. So this would be called a virtual image. In this case, this image is larger in size, okay, and it's located behind the mirror, located in the mirror, behind the mirror. Both are valid, and also this candle is right side up, or what we called erect. All right, so right side up, or it's also called erect. So remember, the pinhole camera gave you a real image, so there was no mirror, but it was captured on a piece of paper and it was upside down. Okay, whereas a plane mirror is the same size, but it was in the mirror. You can't capture that image on a piece of paper, and that's a virtual image. So in this case, this will give you virtual image, larger size, it's right side up, and it's located in the mirror. Okay, examples of where you use this mirror. Well, some of you use this mirror every day. I call it the pimple popping mirror, and basically it's those mirrors that make your pimples really large so you can pop them. All right, so I'll just write that. This is your pimple popping mirror. So it pretty much enlarges your face. Enlarges your face, whether you like it or not. All right, so here is a diverging mirror, and some people can guess, well, this mirror must make things smaller, and they do make things smaller, and we usually use this in a security mirror. For example, if you're in a grocery store, they might have these mirrors and you can see the entire store. That's because they take the image and make it really small so you can see everything. All right, now let's apply the same rules. Remember, it's the same rules. So let's do the first rule over here. It's going to be parallel to the PA, so parallel to the principal axis. So this here is your PA. So I'll have my instructions over there that you can see, and let's draw parallel to the principal axis. So here we are, making sure it's parallel. That looks pretty parallel to me. Okay, hits the mirror, and then it's going to reflect off, and then when it reflects, it's going to go through F. So let's reflect it. Remember, any line that's behind the mirror is going to be dotted. Okay, so this is a dotted line like so. Okay, so here is your light ray coming in. It bounces off the mirror, and there's the dotted line. So that is step 1, okay, in the blue. And I'll just write that again as a reminder. 1, parallel to the PA, and step 2, you're going to go through F. All right, the next step I'll draw in red. again from the candle, I'm going to first go through F and then parallel. So I have my candle over here and I'm going to line it up through F like this. So line it up. So through F, so this is the opposite. It hits the mirror, perfect. And then you're going to go parallel to the PA. So let's do parallel to the PA. I think that looks pretty parallel to me. I hope that's pretty parallel. Okay, parallel to the PA. And it's always the second ray that you want to go back into the mirror if you're wondering, like, how do you know? Is it the first ray or the second ray? And what I mean by second, I guess it's a reflected ray, I should say. It's always the reflected ray that is dotted. So here again is the reflected ray that is dotted. In the plane mirror diagrams, it's always the reflected ray that is dotted. Okay, I'm going to write out these steps. Step 1, you're going to go through F, okay, looks like it's going through F, and then 2, parallel to the principal axis, okay? And of course you need your eyes to see this image, and so don't forget to draw that eyeball so you can see. And when you do see this, you're on the same side as the object, so this is your object. And the image is where they intersect. So now here the intersection, and notice that you start here at the tip of the candle. So this here is at the tip of your candle there, and then there it is. Now this candle is itty bitty bitty. I made the flame really big, but yes, itty bitty bitty candle. Okay, so this here is your virtual image, also virtual image, and it is smaller in size and it's located in the mirror because all virtual images are located in the mirror. Okay, and then it is also right side up, or in other words, erect. So those are the qualities or the properties of this image, which is much smaller, virtual, located in the mirror, and right side up. Examples of where you guys use this every day is a security mirror, mirror. And some of you are going to learn how to drive in the future, the near future. So this would be also your side mirrors. All right, so side mirrors. You'll notice that it has a little sign. It says objects may be closer than they appear. And the reason why is that it is actually a diverging mirror. It makes the cars look smaller. And when cars look smaller, they look like they're farther away, but they're not. And that's why there's that warning, objects may be closer than they appear. And so that's where that warning comes from. So side mirror in a car. That's another place you would use this diverging mirror. Okay? So this is a nice little summary of virtual images using curved mirrors. In the next video, I'm going to show you how to get real images, not virtual, real images using curved mirrors. We'll see you then. Bye.